Hi, Erik. How are you doing?
Good. How are you?
Good. Great. Good to see you.
Yeah, good to see you too.
Welcome, everybody. Welcome to another round of Geek Talk under SQL Server Geeks. And this time I have the world famous Erik with me. And whatever I tell about him would be less. He is one of the finest experts we have on the planet on SQL Server performance tuning and query tuning, and one of those few people who I really follow quite actively. And it's good to have him. Also, you can understand by now, because you have been attending many of our Geek Talks, that he is also one of the speakers at Data Platform Virtual Summit. He's delivering a breakout session and an 8-hour class, which you cannot afford to miss because it's very low priced. And we are very thankful to Erik that the class is being recorded. So you will have 12-month access to the class after it's delivered live. And I'm donning this background. So yeah, the links are up there. Just visit dataplatformvirtualsummit.com and you can browse all what we have to offer. 200 breakout sessions, more than 30 classes to choose from. All the links are there in the chat window. So welcome, depending on where you have joined from. Good morning, good afternoon, good evening. And I have informally introduced Erik to you, and I will hand over the stage to Erik now. So Erik, why not first introduce yourself to the audience, and then we can get started talking about performance tuning, a subject that you really love.
Sure thing. I don't know. There are subjects I like a lot more. So if you ever want to talk about like wine or steak or whiskey, like it's a lot of other things that we could talk about. They're probably more entertaining. But yeah, my name's Erik. I'm an independent consultant here in Brooklyn, New York. I specialize in SQL Server performance tuning, not just the queries, the hardware, the indexes, the whole surrounding environment. So I get pretty involved in that stuff on a, I don't know, I guess it depends day to day, week to week, month to month basis with people. And it's a whole lot of fun because there is always something new and exciting going on. Well, I guess something new and exciting that someone's doing wrong to SQL Server.
Yeah. Absolutely.
Exploding consequences.
Great. Friends, that's how Erik is. His introductions are always like that. So don't expect that I have X years of experience and I have this credential, that certificate. It's never going to be like that.
No.
Right. So friends, let's get started and, let's talk about performance tuning and query tuning. But before we jump into this, complicated swimming pool, some housekeeping. Some of you are in Zoom. That's great because you can use the Q&A panel to ask questions. If you are watching this live on YouTube, there's the chat window. You can put your questions there, and our colleagues Satya and Aarti who are helping us as moderators, they can take your question and throw it in the panel in the Zoom tool, and we can do that. If you are on SQLServerGeeks.com/live, if you're on that page, the Zoom link is there, and you can pop over inside Zoom. Even you can do that. So let's get started. Erik, my first question, of course, on behalf of the audience here is that you are
heavy.
You do so much stuff around query tuning and performance tuning, and I know you will have so many different kinds of advices. And my experience is whenever I look at a customer or a production environment, everyone is doing a lot of different things, and there's no two customers doing the same thing. I see that, and all of them have different approaches. Let's start by asking you, what are the things that you see they are doing wrong, and you would advise them not to do that? Things that really surprise you, and you're like, why are they doing this?
Well, it's funny because whenever I start looking at a server, I will usually notice the same few anti-patterns from I guess starting with a server design perspective where, people just have a real misunderstanding about memory in SQL Server, how it gets used, that memory is a shared resource between so many different components. And they really just underestimate how much, of a big deal memory is. It's, like they might have some vague idea that SQL Server uses memory to cache data pages, but they don't really understand all the other sort of lower level caches that end up there, like the plan cache and some other things. And also that memory space really is shared with queries, right? Because, every query needs a little bit of memory. Some queries need a lot of memory depending on what they get up to. So, if you see queries with large memory grants, that memory has to come from somewhere. And if you don't have enough to, say, cache the normal set of data that you're working with, you can have a really tough time when queries start coming along and asking for memory and start stealing space from, from the buffer pool. So that's usually one of the first things I see is just, sort of a misunderstanding of how SQL Server uses memory. And then once you get on from there, I think generally people are okay with the settings at this point. I don't get too many. I used to get all the time the big question. The first question is, how do I set max stop? I think that's pretty well settled, and a lot of that has to do with Microsoft really stepping up their game with the installer. Things have gotten a lot better there, and just the advice has sort of proliferated enough. But what's strange is as much as the administrative stuff has proliferated through like best practices, it's gotten down to a lot of sysadmins or people who set up SQL Server, maybe not like a dedicated, or as a phrase I got from Aaron Stellato recently, the involuntary DBA, which I love. And so it's funny how that stuff has, made it around the community, and even to people who aren't directly in the community, but, have to deal with SQL Server. But a lot of the anti-patterns in code still exist there. So, you'll still see a lot of people, doing bad stuff with functions, table variables, sticking functions in their join or where clause, is null, coalesce, all that stuff. So, it really is a sort of a similar set of basic fundamental issues that I see people running into. But there's like beyond that, there's always like some funny repercussion or some funny thing that goes wrong because of it. But it's usually the same, basic few things.
Great. Long answer there. Yeah.
I hear we have some time to kill. So.
Yeah. Of course.
Silence is deadly.
Yes. Were you speaking at SQL Bits today or maybe tomorrow or something?
No SQL Bits for me this year. Oh. Had a lot going on.
Great. So too many things, Erik talked about. So one is, of course, memory, the kind of one of those least understood things inside SQL Server. And that's one of the takeaways. As he says, configuration is all good nowadays. And, things are settled with cost threshold of parallelism or maybe max stop. But, coming to CTP, I think the default value still is 5, right, Erik? As when we do,
the default value is still 5, and there's not a lot of feedback in the there's no feedback in the installer for that just yet. Yes. It would be interesting to see how they handle that. That is, that's like a really important setting when it comes to parallelism, right? Like max stop will control the number of schedulers that you can use or that a query can use, and the number of threads that a parallel branch can have. But, cost threshold parallelism really does set the bar at which a query should even be considered for a parallel plan. And, environment to environment, that's going to vary so much. And if you really do have a purely OLTP environment, even at 5, like your query shouldn't be approaching that. But unfortunately, a lot of people do have that sort of mixed workload. They might have poorly tuned OLTP environments, and all of a sudden parallelism just runs rampant on the server because, they can't, all their queries just need it, or else they can't finish quickly.
Great. Erik, another thing about performance tuning is when I see a lot of customers running a lot of queries that are around weight statistics and weight types. And I see many of them are picked up from the internet, from SQL skills, from XYZ sources.
Sure.
People are, collecting all of that data, dumping them into tables, but they're doing all of that stuff. But I have rarely seen people trying to take action on that. It's not really very actionable. Where do you think they're going wrong? I mean, you're collecting it, but you're not making it actionable.
Well, so when you want weight stats to be actionable, there really are very few of them that you can go out and immediately do something about, right? If you see a lot of the CX weights, you can check to see if, maybe you have your parallel setting still. I apologize, there's going to be a traffic jam outside. Busy Brooklyn morning. But you might see that, your parallelism settings are still at the default, which is usually a bad choice for most modern servers. You might see that you just have you might have like there was a code release recently, and you have some new queries that just aren't behaving the same in prod as they do in dev. So I mean, CX packet is at least somewhat actionable, and what kind of queries to look for, right? What settings to look at. But things get a little bit trickier, I think, when you start thinking about stuff like SOS scheduler yield, or people, that's like very confusing weights like that. Some of like the page latch weights, and then there are weights that can indicate that might look like you have a certain stress on a system, but really indicate you have a completely different stress on the system. I think the page IO latch weights, where you're reading pages from disk into memory. If you see a lot of those weights, you might think, oh boy, I just don't have enough memory in this thing. What's going on? But a lot of the times, what I run into when I see a lot of those page IO latch weights are something I talked about before, with queries just getting these gigantic memory grants and taking big chunks of space away from the buffer pool. And then when queries have to go and try and run and read data, they're like, oh, I have to go to disk for it. So a lot of the times, those weight stats, are not actionable because there are so many potential different choose your own adventure paths that you can take with them. And, and for like tuning a single query, I have almost never, ever found weight stats to be a useful, actionable thing.
Right. And also, they need to have some kind of baselining or benchmarking to really compare the numbers that they are observing, whether these numbers are really high or low. And in many cases, those benchmarks are also missing.
Sure. Yeah. Well, I mean, how can you expect people who don't know what they're doing with weight stats to know how to take a benchmark, right?
Right.
And a lot of that is Microsoft's fault. Microsoft that their built-in tooling for things is just not made for people to do that sort of time trended analysis, right? Like everything is just in the aggregate.
Yes,
it's just dumped in and continues ticking up.
Yeah, I remember something in 2008. I don't know if I even remember the terminology correctly, but there was some performance analyzer or something, but that never kicked off.
No.
Well,
And like I've had a number of posts and user voice requests about how Microsoft needs like better views with some time slicing in them for stuff like weight stats, for stuff like just like what queries were running when. And Query Store kind of helps that a bit, but just not enough people are not enough people have Query Store turned on. I do see a lot more people going towards versions of SQL Server now that at least have Query Store in them. Still a lot of folks straggling behind on 2012 and 2014 though.
Right. Friends, while I keep talking to Erik about performance and query tuning, I know all of you are here because you want to learn about that. So have your questions coming into the Q&A panel, and very soon we'll get on to your questions. Erik, another thing about, and I know you recently had a chat also in one of the 8KB sessions about statistics. Yeah. So stats, histogram, there's a hard limit of 200 steps.
Yeah.
I don't know if that question came up, but that is a very common question that I see, and I know that it's not going to change, but doesn't really make sense to have that value change, because when your data distribution is so badly skewed. Your thoughts?
Well, there's two interesting ways to think about that. Is should we have bigger histograms in general for like when tables scale past a certain point, right? Like, is there some number of rows where it starts to not make any sense to have that smaller histogram, because it becomes very, very difficult to accurately model based on a sample, like what data looks like in there. But then you have to consider also that when stuff gets that big, sampling it becomes more difficult generally, right? So like it might be that if you do a full scan, you might get a good 200 step histogram. It might be if you do like the default sampling, you might not get a good histogram. So it might not always be a matter of having more steps. It might be a matter of having more sample. And we've had something for a while now. We've had filtered indexes and we've had filtered statistics. So if you find that there are regions of your data that are skewed, that, you know, whatever sampling algorithm you do when you update stats doesn't pick up on it. Sometimes it's worth creating filtered indexes or filtered statistics to really capture that region, right? Like really get like a better, like get a, like give that region its own 200-step histogram, so that you're not sitting there relying on, you know, a 200-step histogram for the entire table to accurately portray the data that's in there. So, you know, it's like, well, like, you know, other database platforms do offer the, like, you can use larger histograms and stuff. I just don't know that it's going to fix every single problem, right? Like,
Yes.
if we had another 200 steps, would we really get like the data we need in there? But, you know, I think the better answer is to, you know, create more specific statistics on the areas of data that you care about.
No, absolutely. I have experienced that filtered stats and filtered indexes are very powerful, great tools out there, but I mean, least used. And surprisingly, many folks don't even know about it. I don't know. What's your experience and feedback? Do you see people really using filtered stuff?
Filtered statistics, no. I think those are a little bit more exotic. But I do. There is now
okay.
A truck outside.
Let him enjoy.
But, yeah, right. But filtered indexes, I do see, and I also see a lot of dismay around filtered indexes, because, you know, if you have you know, your filter definition on, you know, some expression, and then you're in your code, that expression is based on a parameter value, your filtered index does not get used. So it's a little unfortunate. So I don't see it enough, though, and I don't see it enough in the right places. I think you know, that and like stuff like computed columns really do pay a lot of dividends as soon as people learn about them. But like leading that horse to water is where some of the difficulty sort of comes in.
Right. No, in fact, this conversation also reminds me of the fact that when we talk about some, you know, so-called hidden gems, you know, some really great things in SQL Server, which people are not using. Another thing comes to my mind is partitioning. And just a few days back, we were having another Geek talk where we talked about partitioning with Erik, and we had the same consensus that that's also a great tool, great feature that could be implemented with large tables, but seldom used. But the question here is, partitioning is a good so-called, let's say, manageability feature. Does it really help in performance as well in any area?
No, not that I found. I found like at best you can get like an equivalent. At best you get equivalent performance. And, you know, what gets lost, like people think that partition elimination is magical, right? Like you just go, like if you just eliminate a partition,
right,
you all of a sudden like will just get better performance. But really that's the index, right? Like if you have a good index on a table, you can seek right to that chunk of data anyway, and you can eliminate a lot of other things along the way, right? You don't have to read all of the data to get to that if you have a good SQL index and you write your query in a way that you can take advantage of a good SQL index. So, you know, a lot of the query patterns that will hurt a regular table will hurt partitioning. A lot of the bad indexing patterns that would hurt a regular query on a regular table would hurt a partition table too. And, you know, you hit the nail on the head earlier when you said it's a good feature to manage data with. If you need to, you know, swap in stuff pretty quickly, if like you have well-defined chunks of data you need to get in and out of a table for whatever process, it's great for that. It's wonderful for that. But if you're doing it just for performance, you know, the number of tricks that I've had to see over the years just to coax the optimizer to start eliminating partitions is crazy. Like stuff where I think like I've seen like Itzhak Ben-Gan and Paul White cross-apply the partition function and have that equal a thing. And it's just like, if people are having trouble tuning a query against a regular table, adding that layer of complexity isn't necessarily going to like just fix it, right? Like just adds in more stuff that they might have to chase down and get more and more crazy with in order to get the type of performance that they're after.
Indeed. Erik, let's talk a little about about extended events. Now, again, with extended events, because extended events is lightweight, and of course Microsoft supposedly yes, I'm just coming to that. So what has happened is, because of this documentation, you know, where it calls it lightweight, I've seen people configuring extended events with a lot of sessions, trying to collect a lot of information, and more than 90% of that is useless. But very recently I saw cases where someone was capturing execution plans, query plans, as part of the sessions, as part of the configuration, that really slowed down things. So according to you, what are those some of those best practices, do's and don'ts with extended events? Because people really need to know that well.
Well, I saw a lot of open space with extended events because, I think, I've had a little bit of the opposite experience where I just have I don't run into people using them for anything at all. And, I think that people sort of have the wrong idea about them. I like whatever you are going to do with Profiler, you should be able to do with extended events. But extended events is just a lot harder to get started up with. I wrote a script. Well, I guess I started working on it earlier this year. It's pretty good now. I'll stick the link to it in chat. It's called SP_human events. And what it does is it tries to make extended events a little bit more accessible to people. So like you just have a sort of limited number of things that you can profile your server for like a limited amount of time. And you kind of go in and just grab the stuff that Profiler would grab, right? Like the stuff that you can do things quickly with extended events that might have taken a lot of setting up, guessing, trying to figure stuff out, a lot of that. So I don't pretend to know every single best practice and every single, thing that you should do with extended events to keep your server from, experiencing problems with the amount of data you're collecting. But I do try to put some pretty reasonable defaults in there so that you're not going to overwhelm anything on its own. That being said, whenever, like, this goes for Profiler too, not just extended events, but whenever I've, let's say you have a workload, it runs for 15 seconds, right? And now all of a sudden you're measuring it. And you set whatever timer for 15 seconds, and you're checking your watch, and hit the stopwatch, and you're ready to go. And now you're watching it, and all of a sudden it takes like 20 or 25 seconds. You're just like, well, what happened? It's like, well, now you're collecting all this information about it. It's very hard not to introduce observer overhead. And, a lot of the monitoring tool companies out there that are around that have good mature products do a pretty good job of that. But, extended, I think of extended events was really as low overhead and as manageable and as usable as Microsoft says it is, a lot of those monitoring tool companies would be stepping away from traces and other things and moving like explicitly to extended events for their whole product. But you just don't see that sea change in the way monitoring tools work right now. They might have a couple things for like deadlocks or blocking that use extended events, but generally all the query performance data they're gathering isn't coming from there.
Great. Friends, take a note of that link in the chat window, and we have Greg who has also put it there. So that's ericdarlingdata.com/sp_human events. Take a note of that. Erik, about the execution plans. Now,
oh boy,
again, common questions. So when the plan is small, it's kind of relatively easier to find out where could be the problematic areas. There are some hints, like you see warnings, you see spilling happening, people go and observe the the amount of data, cardinality estimation. But
sure,
things like when the plan is really huge and you have a performance problem, how do you begin looking for the right things in a big plan?
Sure. So I have a couple rules of thumb when it comes to big queries and big plans. And that is, if I can't see everything clearly, if I can't immediately make sense of what's going on where, neither can the query optimizer. There's this weird fetish with developers where they want to do everything in one query and they think that's somehow the most efficient or effective way to write something. Or you'll have that query that, does what someone wants, or like started off doing what someone wants. And then over the years, people have just sort of tacked on left joins and views and whatever else and like weird little aggregations because there's like, oh, we just need this one other thing in the report. And I have a hard time mentally concentrating on that. Now, I'm going to separate things into two areas. If you're on a newer version of SQL Server and you're getting an actual plan and you can look at the operator times in the query plan, it's a whole lot simpler to break down where you hit an issue in a big query. You can see if there's a single bottleneck in one area of the plan, or you can kind of see that okay, this plan has 1,000 operators in it and they all take 100 milliseconds. This query is just a product of the amount of work that it's doing. It's not like anything is wrong in the query plan. It's just big, right? We just have to do a lot of work. In estimated plans, you don't really have that same luxury of getting the time spliced breakdown of things. You don't have that. right? So it's like, it's up to you to maybe start doing yourself and the optimizer a favor and breaking those larger queries down into slightly smaller chunks that are a little bit more manageable. Temp tables are a great thing for that. If you can take like certain parts of the query that maybe have like logical stopping points, whether it's a derived table, a common table expression, like a little subquery or something, if you start breaking the query down into smaller components, you might find that you have faster queries just from breaking things down. You might find that, taking things and putting them into those intermediate steps has just gotten you better performance on its own without you having to figure out what was wrong with the big query. Because oftentimes what's wrong with the big query is that it's too big. So, I guess specifically if there were things that I were going to look for in a query plan that would spell trouble, depending on how things ended up working out, depending on if estimates were good or bad. Key lookups, nested loops, joins, sorts, eager index spools are a big one. Table spools are another one. There's just there's certain things that I keep like some peripheral eye out for, but a lot of the times even in a very big plan, things can be misleading, right? Because they're except for like parallel merge join, there's nothing that I really just see and shriek at.
Great. Erik, you mentioned about temp tables, and again, when we talk about temp tables, there are so much of discussions and debates between temp tables and table variables. So
there's no debate.
Yeah. Today, the audience does know, okay, what are the advantages of temp tables? You can have indexes, stats, and all that is there. And I understand table variables could be good for small data, because, temp tables, when you create a table, of course, it has to go through the allocation and deallocation code and all of that. Where do we use table variables? I mean, because temp tables just seem to be doing everything. And with table variables, there are issues. There are so many issues. And, Microsoft is coming up with new features. Those are really fixes, so to say, with past implementation.
Getting better. So when do you use table variables? Table variables for me work best when either you have very, very high frequency code executions over small amounts of data where the shape of the query plan does not matter much. But I think as soon as you start filling up or populating table variables with any amount of data and you need to join them off to other tables, you are making a mistake. You get those bad estimates from table variables, and those bad estimates tend to propagate throughout the whole plan. And it can kind of feel like parameter sniffing, but it's not. It's just that, table variables don't have those column level statistics on them that allow the optimizer to make sort of better guesses downstream. Apart from the low row estimate and and like that, you just don't know what's in there no matter what. If you could have one row in there, and if that one row is a very popular value, you could make a very, very big mistake in the query plan. So it's not really the amount of data, it's how that table variable gets used. If you populate a table variable with, some I guess a decent chunk of data, right? You could, as long as that table variable isn't off going to go touch other table variables, you could come up with a perfectly fine plan for just that table variable. That one row might not make a big difference if you need to aggregate or do a sum or something on 10,000 rows, right? It's not going to make that huge of a difference. So for me, it's about placement. If you have very, very high frequency execution code, there's less overhead to the creation and population of the table variable, because you don't get those statistics. So it can be very good for that. But as soon as you need some different, or as soon as the shape of the plan might matter, depending on what data goes in, you might want a different, you might want a bigger, beefier execution plan. Table variables just stop making a lot of sense.
Great. So, Erik, a lot of questions are coming in from the audience, and I think I have asked you enough. So it's time for the audience to ask questions. And friends,
I love audience participation.
Yes, indeed. A lot of questions queued up already. But before we jump into the questions, just final words not final words, second last word, because the last will be Erik. Is about Erik's class, 8-hour class, which is split into 2 days, 4 hours each day as part of Data Platform Virtual Summit training class. This is the Beginner's Guide to Advanced Performance Tuning. Quite exciting title, Beginner's Guide to Advanced Performance Tuning. So it's start to finish. And again, thanks to Erik, this class is going to be recorded, so you get to attend live and you get the recordings too. And as of this moment, this is 50% off. So just go to dataplatformvirtualsummit.com, sign up for it. There's a lot more to explore on the website, all up to you. Now is the time for questions. So I am just switching on the Q&A panel, and
All right.
a lot of there. So let's start with the first one.
Mm-hmm.
I think the first question was already answered, Erik. It says, hi, Erik. What
Hi.
patterns do to look in execution plan? This question is from Yog. I think you talked about anti-patterns, but I think, is that the question, the same answer there? For slow running queries. Yeah.
So what anti-patterns do you look for in query plans? Well, you know, it's a big question,
Yeah.
because you know, like I said before, a query plan that looks one way might be fine for one set of parameters and not so fine for another set of parameters. You might see something like that I hate, like an eager index spool in one query plan that maybe builds an index for like 10 million rows. That's really bad. But you might see another plan where it builds an index spool for like 1,000 rows, where it just makes no difference whatsoever. So you know, really, it's what I think when you're troubleshooting query plans, you know, you might be able to find some, you know, forensic pattern in the estimated plan that looks suspicious. It really is a matter of getting the actual plan and looking at where things line up with reality, right? Because that estimated plan is really just all estimates. There's nothing about reality, and there's nothing about what happened along, like when the query actually ran. This is like, you know, if I was planning on driving through Manhattan on Tuesday at like 4 a.m, I would probably have a pretty easy time just buzzing right through Manhattan. Not a lot going on there. If it was, you know, Friday at 5 p.m. and I was trying to get through Manhattan, it might be a totally different story traffic wise. So like whatever I thought was a good idea for driving through Manhattan on Tuesday at 4 a.m. is a really bad idea for driving through Manhattan at 5 p.m. on a Friday. So, you know, it really is a matter of, you know, looking at the query plan, getting the actual plan, and then seeing how the estimates lined up with reality. That's really one of the best ways to go about it. The other thing that's important with a query plan is not to look at it as an isolated data point, right? It's a good data point. It's a good set of data to have, but it's not the only set of data you have. Those query plan DMVs relate to a whole lot of other DMVs in the system that talk to you about resource usage, about how much CPU, how many reads, how many writes, all this other stuff that the query did. And, you know, you can find a lot of good data in there that either backs up that it was a good plan or backs up that it was a bad plan, or that like the plan just needs tuning, right? Like there might be missing indexes somewhere. You know, you might see that the plan was cost like 0.000 something query bucks, but it ended up running for like 5 minutes. And you might think that maybe that plan didn't line up with the reality of what the query needed to do. You know, you might see that a query ran for, you know, 5 minutes, but only used like a few seconds of CPU. And you might just think, oh, well, that query just got blocked or something. So don't think of query plans as just an isolated data point. Always try to capture as much information as you can about, you know, what's going on with the query. I have a little acronym that I use called QTIP to get the right information to tune something. So I want to know the query plan. I want to know the text of the query. I want to know the indexes that I have available, and I want to know which parameters were used. A lot of the times when a query plan, or rather when an estimated plan does not line up with the reality of the execution situation, those parameters are going to be the key to figuring out exactly what went wrong.
Right. Great answer there. Next, Athar has a question. I think he knows all the different things with parameter sniffing. I mean, option recompile or something, but probably the question. Yeah, parameter sniffing, how to identify them.
How to identify parameter sniffing? Well, it's fun to do in the plan cache, because you will have this query that looks like a tiny little lightweight little nesty loopy thing that didn't really do much work. But then if you look at the execution metrics of the query, you'll have you know, really you have like, you know, a query that ran for quite a long time, probably getting stuck somewhere. So when it comes to identifying parameter sniffing, it really depends on at what point in the parameter sniffing issue you're trying to find it. SP who is active has a little known parameter, and I want to make sure that I get the parameter name right so no one yells at me later. But it's one that if you are looking at a server where someone is saying, hey, we have a query that's used to be fast, but now it's running really, really slowly, there's a great parameter in SP who is active called get average time. So it's get underscore avg underscore time. And what that'll do is it'll like give you the same output that SP who is active normally gives you, but it'll also go and look in the execution plan DMVs, and it'll look to see how long your query executed for on average. And if the average time that it executed for is very low, but the current time is very high, you just might be dealing with a parameter sniffing situation. Catching it later on gets a lot tougher because you have the plan cache, which is just full of lies, and if you're lucky if the plan cache even existed for as long as you've had your problem. I don't trust a plan cache to have data in it from like 2 days ago at this point. Every server I look at, the plan cache is just like our oldest plan is about an hour. And so later on, it gets a little bit tougher with the plan cache, but other tools like Query Store make that a little bit easier. They even have like reports that you can click on and get like a list of regressions and stuff like that. So there's all sorts of, and if you have a monitoring tool, that's another great way to do it because most monitoring tools will give you like, like the query, how long it ran for, the parameters that went in there. If you really need to fix parameter sniffing problems, it really is just about knowing your workload, knowing the stored procedures or the code that takes parameters that are running, and sort of isolating the ones that people complain about. And if you have the sort of access to the system where you can profile it, I don't mean using profilers, I mean where you can profile the system in some way, you can use whatever tool you feel the most religious about. If you want to like profile a system in some way and just like collect information about, what parameters are going in, what people are executing, when things go wrong, then that's where you can start going in and experimenting with different fixes and solutions and sort of learning where the real problems lie.
Thanks, Erik. Next question is, any thoughts on scalar UDFs? You will love this one.
Yes, don't use them. Unless you're a consultant who is trying to write a demo to show how bad scalar UDFs are. They really don't have much of a good place in SQL Server. I guess they're fine if you just need to use them to set like a variable for something, right? Like if you just like have maybe like a user settings table and you write a UDF, it'll go look up a setting for a user and set it to like a variable for something later on. Fine. I guess that's okay. But, if you stick them in a query, everything just goes terribly. Especially, like you see them a lot in reporting queries where people need to do like formatting of some kind and they've just like gone off the deep end and they've like encapsulated like some other formatting code inside of a function to reuse it. And, the real downsides of them are that, they don't run once per query. They run once per row, and they prevent the query that calls them from going parallel, which can be very important for some queries like we talked about. So just avoid them. They're not a very good practice at all, aside from like very, very controlled circumstances. And even SQL Server 2019 with the scalar UDF inlining, and it seems like every single release, they have some new restriction on them, something that didn't get tested along the way, something that a user finds. And, right now, there's just not a big population of people on SQL Server 2019. As that gets more and more adoption, you're going to see more and more problems and more restrictions coming out of there. It's not that I don't like the feature. It's not that I don't like, what the problem that it's trying to solve, but it's V1. It's, running into a lot of stuff. And there are a lot of functions out there that just aren't eligible for inlining. And I don't know that they ever will be based on the complexity of them. So, you just can't count on that engine feature, which is, is a great idea, but, maybe just isn't quite up to solving every scalar UDF problem in the world, which is understandable.
And that is part of the answer for the upcoming question, which is intelligent query processing intelligent enough to tune queries automatically?
No. It's cool, right? It's neat stuff to see. Like I like the idea of adaptive joins, right? Because you no longer have that like YOLO, I'm gonna nested loop my way or like hash my way through this query no matter what. It's nice to see things like that. Memory grant feedback is a big one. We talked about memory a lot earlier. Memory grant feedback is a nice way to start getting maybe like towards a middle ground memory grant that makes sense for queries. But, it's just what you should keep in mind about intelligent query processing is that all it can do is work with what's there. It can't fix your code for you. It can't rewrite queries for you. It can't tune in. It can't like give you the best index. I know Azure has the indexing feature where they can try stuff out, but the chance of that coming to the box product of anyone like being okay with spending those additional CPU cycles doing stuff, Microsoft can't up in Azure because it's their CPUs. They can do whatever they want with them. They can spend them on whatever indexing testing they want. But like in the box product, is just I can't imagine anyone like just saying like yeah just go test indexes normally, especially like software vendors. They would freak out. But like intelligent query processing can certainly help a lot of things, but it's still up to people to like get it across the finish line. There is still a lot of bad habits and bad practices in the way people write queries, design indexes, or don't design indexes that need addressing before the intelligent query processing stuff this goes well beyond what it can do.
No magic bullet.
Not usually, no. I mean, there's certainly stuff that has gotten better. There's certainly stuff that has been improved upon. But boy, oh boy, Microsoft's in such a tough position because you want sort of you want those safety nets. You want that sort of automation. You want that intelligent query processing. But whenever you make a change to the optimizer, someone gets real mad about it.
Well, friends, with this, we come to an end of the Q&A from the audience side. Oh, there's one more question, is it?
Already?
Okay.
One more? Okay, fine.
One more. Let's take that up. Indexing for query tuning, what to take care of? Again, long subjective.
Yeah, sure. So, if you want to think about when you start thinking about how to tune indexes for a query, think about what indexes do. Indexes put data in order. Data being in order helps a few different parts of a query, right? It can help the where clause because it makes data easier to find. It's a lot easier to find sorted data than unsorted data. It can help the where clause. It can help your joins because it's a lot easier to put data together when it's in order, right? You have a table of data where the join columns are in order, and that's usually a pretty helpful situation. And then you also have other parts of the query where data being in order is very helpful. Obviously, order by, because asking for stuff in order. If it's already in order, then it's free. Group by is another good one where it's a lot easier to group data once you know the order that it's in. And then if you have stuff like windowing functions, row number, rank, dense rank, all that stuff, whatever your partition by, order by clauses is for those, having that data already in order makes those functions a lot easier to implement. So whenever you're indexing for a query plan, start by figuring out what your query is doing and what's important for that query to be able to do quickly. Whether it's find data, order data, group data, you might have a data with no joins or where clause, but it's just like select columns, group by, and you can go, okay, I can create a good index to help that group by go more efficiently.
Really, and then you can see that ordering the data with the help of index really does the job. I mean, that's one of the key things which we don't really focus about, and we always think in terms of like seeking and lookups and whatnot, but that's not the right way to think about indexes.
Right. People get mad at indexes whenever they see a scan. They're just like, this query can never be fast. It's over with.
Great. Right, friends. I hope, and we all hope here, the team, that this was really worth your time. 45 minutes with Erik Darling. And, the subject is so huge and so complicated at some point. Thousands of Geek Talks are not going to be enough. People have been working on this subject for years and years, and we continue to work even more. And as things get more complicated, things are not getting easier. As Erik said, there are improvements, but it's also getting more complicated.
Yeah, every new release, it seems like there is a new thing to fix.
Yes, and there's more work. And then
hopefully, fingers crossed.
Hopefully, yes. So we
not ready to mop floors yet.
Microsoft is keeping us busy all the time.
Yeah, sure is.
Right, friends. So with this, we come to an end of this Geek Talk, and we have Geek Talk scheduled already for October 15th. So just go to sqlservergeeks.com/live, and the next Geek Talk is all up there. I think it's with Rob Sewell on PowerShell with SQL Server. So that's the next Geek Talk. And yes, do
Tell
take
Rob
a
I say
moment.
hi.
Yes, of course. And yeah, do take a moment to visit data platform virtualsummit.com. Go on to sqlservergeeks.com, and you have a lot of information there and the summit. Make sure you join Erik's class. It's a great opportunity, I would say, and you should not miss it because you're going to get the recordings too, apart from attending live. With this, any final thoughts, Erik, before we close the show?
Sure. Just a little about the class that I'm teaching. Usually I teach pretty advanced query tuning topics, and I just start advanced and stay advanced the whole time. But what I would find when teaching those is that a lot of beginners would show up who just need exposure to the advanced stuff, but maybe aren't quite ready to just dive headfirst into it. And I really wanted a chance to teach a class that helps people learn how to avoid query performance problems in the future, right? So writing code and designing indexes so that you don't run into big problems down the line when things are a lot harder to change, learning what works and what doesn't up front. A lot of the people who've been working with SQL Server for a long time have a lot of bad habits already, and it's a lot harder to break them of those bad habits. So I want to get people who are fresh into things, who who really want to learn the right way to write a query, design an index, the right feature to use, the right temporary object to use, all that stuff at the right time. So there's a lot that I want to teach people because really. Beginners are the future, right? They're the people who are going to be writing queries, designing stuff for years to come. And, I want to teach them how to do things right, because it's a lot easier to learn something the right way the first time than to have to unlearn something years later after you're just so set in your ways.
Indeed. Amen. So data platform virtualsummit.com, and Erik has listed down all the modules, and quite big description has been put, so you really understand what are the takeaways. So just go to data platform virtualsummit.com. On the menu, go to learning, training, classes, and you will find all the details. Thanks, Erik, so much for joining us today. It was a pleasure talking to you always. And friends, thanks for coming on board, and yeah, see you soon in another Geek Talk. And
Absolutely.
Have a good day. The rest of
Take
it,
care.
whatever
Bye.
is left. Thanks, Erik. Bye.
Bye.
Bye, guys. Thank you.